Hi, this is Mr. Goodley. This is Kitchen Chemistry 2020. We are possibly going to be in Zoom meetings for the next year. So, seeing as we're going remote, we're going to go ahead and take off our mask. So thanks again for being here. Today we're going to learn about elements. I have the periodic table. We're going to try to see them in case we don't get a chance to see them during lab time. I have a few tools to help me. Number one, a Geiger counter. A Geiger counter will click about 15 to 20 times in a minute. If it goes more than that, a substance is radioactive. Okay. I also have a balance. And the third item I have is a magnet. So I have some tools to investigate some things and some properties of some of the elements we have. We're going to go alphabetically. So I've got the name and symbol. We should know and memorize the name and symbol. Aluminum, Al, is our first element. So alphabetically, aluminum, and aluminum foil comes like this. We are all familiar with aluminum foil, okay? Often people will call it tin foil. It's not tin foil, okay? It's made out of aluminum and not tin. So that's our first item. Our second item is also aluminum foil. It might look like this. Okay, aluminum foil is very useful. We use it all the time in any number of items. Here's a small bottle of aluminum foil. Okay, we can see it comes in tiny granules. It can also come as a powder as well. Okay, powders are highly reactive. And let's go ahead and bring our magnet near our aluminum foil. And we're not getting anything. Okay, aluminum is a shiny metal, and yet it is not magnetic. I also have a balance, and I'm going to weigh some aluminum foil. And if I put it on my balance, and let's see if it'll stay there. Do you see the balance there? Oh, no, it's going to slide off, so we'll lower the balance down a little bit. Sometimes we're going to hear more clicking than others, okay? If we weigh the piece of aluminum, it will still be aluminum, so we don't have to worry about weighing the aluminum, okay? The weight of the substance does not tell you what the substance is, okay? So that's our first object. We can see other objects made out of aluminum. Here's a walker from my father that was made out of aluminum. Any number of items are made from aluminum because it's lightweight and cheap. Our first item is aluminum. Our next one is calcium. So calcium, the symbol is Ca. And let's get a container of calcium. So calcium you might have heard of as being found inside of drinks and milk and all different substances. Okay, calcium, pure calcium, is not the same as calcium the compound. Okay, so there's calcium. It's reacted a little bit. All on its own is a little bit shinier, but over time it will start to turn whitish as it reacts with oxygen. So when it reacts with oxygen, we call that oxidizing, okay? Anytime a substance reacts with oxygen, that is oxidizing, all right? We can check our calcium to see if it's radioactive. It's not. I'm going to turn that off. We can also check to see if it's magnetic. It is also not magnetic, okay? The calcium itself is very, very different than the calcium we talk about in milk or other substances, okay? So please realize that they're different. One is a calcium compound and one is the pure element calcium. So here is the pure element calcium. Some small tiny pieces there. There they are. We're going to put them into water and let them sit there and react. So here's our calcium element Ca. Let's go ahead and go on to our next substance. Our next substance is carbon, C. Carbon's been around for many, many years. So the name carbon, C, and let's get a sample of it, okay? So here's our small sample of carbon. Okay, it's charcoal. It's also found in pencils. The graphite we see in pencils is carbon. We call it graphite, but it's carbon. This is also carbon. It looks like burnt wood. Burnt wood is carbon. Here's a smaller sample of it wrapped inside of here. What we can do with carbon is we can take a sheet of paper and we can write. All right. So carbon is something that just a tiny layer sloughs off, and that's one of the properties of carbon. Again, graphite and carbon are the same substance. Element is C. Oh, did we see that bubbling? Okay. Pure calcium reacts and it bubbles with water. all right? So this is pure elemental calcium, not the calcium compounds that we often hear about. Let's go on to our next element, which is copper. The symbol for copper is Cu. Now, that's tricky because you might think the symbol for copper should be Co. However, you can memorize copper by saying see you later, copper, okay? Funny little thing to say, all right? See you, copper, later, okay? So that's a big ha-ha funny. Police officers might have some copper, but it's shiny, okay? Here's a sample of copper, all right? We might see that as a sample of copper. Pennies, when we get a sample of pennies, okay? Pennies, outside of pennies, are copper. The most important thing about copper is the wires, okay? The copper wires connect our house to an electrical grid, and that gives us our electricity. So copper can come like this. It can also come, and I apologize, I gotta find my sample of copper. There it is, okay. It can also come as little tiny beads of copper, doesn't matter, okay. This is copper, and this is copper as well, okay. It can come as small sheets. Copper's nice, it's super bendable, it's very flexible, all right. It tends to reflect light well, okay. Look how shiny it is, it's shiny. It's reflecting light very well. This is some older copper. Sometimes it tends to corrode a little bit. So copper, a great conductor of electricity. It also came, here's a nail made out of copper. We can test for its magnetic properties and see, okay, that it is non-magnetic, all right? Many people think that all metals are magnetic, but we've seen aluminum is not magnetic. Copper is also not magnetic, okay? Carbon, the charcoal, we can test that as well. Charcoal is also not magnetic. We can test our Geiger counter and use our Geiger counter as well. We're going to be disappointed because we're going to see that almost every element that's out there is not radioactive. But we'll leave this on for a little bit. Our next element is gold. So here's our gold wedding band. This came from my great-grandfather. There we go. It's hard to get off. All right, there it is. There's some gold. When my great-grandfather wore this, when he was married, okay, it looked the same as it is today, all right? Gold is very shiny. It's a great conductor of heat and electricity, even better than copper, but it's shiny. It's been around for a long, long time. The name and the symbol don't match. Gold symbol is AU. Some people memorize that by saying, "Aw, gold, aw." All right, it should be awe-inspiring. All right, so it comes from the Latin aurorum, symbol gold. Here's our gold wedding band. It seems like it's radioactive, but if you have to get like 30 counts per second before you claim something is really radioactive. And we're going to see that at any given moment we're getting a little more radioactivity or less radioactivity, but it's about 30 or so clicks per minute normally. Here's our wedding dishes. The outside edges of these are gold, so these will be around the outside edges, are nice and gold, they're shiny. So we're hoping these will stay nice and shiny throughout our lifespan. Iron, our next element. So here's a small sample of iron, okay, there it is. It's a shiny metal. And here's an older sample of iron. If we look at this, okay, and I'm going to take a few pieces out. Iron is fine to go ahead and touch, and we're going to test to see if it's radioactive. Once again, it's not radioactive. We're going to turn this off because it's just annoying and it always clicks about 15 times per minute. The rust on here is reacting with oxygen from the air. What do we call that? We mentioned it once. Let's see if you can remember it. Yes, it is called oxidizing. So this iron is oxidized. It's reacted with oxygen from the air. Over time, iron does react with oxygen from the air. If there's salt in the air, or if you're in Florida, it might react more quickly. A lot of things are made from iron, all right? It's not radioactive, we can check that. Yep, it's not radioactive, but it is magnetic. Let's go see how magnetic it is. Here's some sample of iron, there they are, okay? So the pieces of iron, okay, quickly and easily attach to a magnet. There are 3 elements that are magnetic, okay? There's different kinds of magnetism, but that's not today's lesson. There's iron, there's cobalt, and nickel. Feconi, feconi. Those are three elements. They're all magnetic, okay? Feconi, anytime you have anything that's magnetic, it is one of those three elements. It is most commonly iron because iron is the cheapest of the three. If we look here, okay, it looks like this might be a piece of tin foil, but what is it? It's made from iron, okay? If we look here at paperclip, here we are, okay, another substance made from iron. If we even go to our stainless, into our knives, and oh, there it is, okay? These are also made from iron, and as you can see, this is rusting a little bit, okay? We like a lot of our silverware to be made not as much of iron, but of other substances because over time iron will tend to corrode a little bit, all right? You would like to have your knives made out of titanium or chromium. Those metals tend to be less corrosive than iron does, all right? A cheaper knife would be made from some iron. So, iron symbol is Fe. It comes from the Latin ferrum. We won't have to memorize it. They used to memorize it at Loyola High School. I'm not sure if they're still doing that or not, but Fe is the symbol for iron, okay? Our next element is lead. Lead comes from plumbum, another Latin name, Pb. It's been around for a long time. So let's go take a look at some samples of lead. If you're on the bass fishing team, okay, you would have used some lead sinkers. Here they are. They're relatively heavy, okay. It's not a shiny metal, but it's more of a dullish gray metal. So here's some samples of lead. Here's another big sheet of lead. Lead is relatively easily bendable, okay. One of the reasons we've used it for a long time, we did use it in plumbing. We don't want to use it in plumbing anymore, okay. Over time, what can happen is little pieces of lead can come off, all right. So as a result of handling this lead, I'm going to wash my hands afterwards, all right? So lead, pretty heavy metal, but what it can do is it can do the same thing as another element, okay? I can write hi on there, all right? So the symbol lead, okay, has the same properties of another element. Can you think of that element? You're right, it's carbon, okay? As a result, both the lead, Pb, and the carbon are both in the same column. You'll see that in the same column because of some of those properties that are similar. Magnesium, here's the next element, Mg. We'll use this an awful lot in chemistry. It's a shiny metal, there it is, okay? And the symbol is Mg, that's nice, the name and symbol match each other. We're gonna see, and we'll use a lot of magnesium. It can come like this, it can come in little bits and pieces as well. But it's a relatively highly reactive metal. It's easy. You can touch a magnesium. It's not poisonous. It is highly reactive if you get it hot enough, okay? You can take these pieces of magnesium and rip them with your fingers. So there's our element magnesium, and here's another small vial of just some ground up magnesium. You can also get this in a powder version as well. Phosphorus, our next element, is a nice one. The symbol is P, phosphorus P. And phosphorus we can see on the end of matches. So if we look at the end of a match, there's a little bit of a white tip at the end. The white tip is phosphorus. Unfortunately, we don't have any other kinds of matches. There are also matches that have red, and the red at the end is also phosphorus. White tipped and red tipped are both phosphorus. Phosphorus can be both white and red. It's interesting that sometimes even the color of an element doesn't tell you exactly what it is. If you see something red, it's not necessarily phosphorus, but either the white stuff or the red stuff at the end of matches is phosphorus. What is our next element? Silicon. Silicon is Si. I have a small sample of it. We'll open it up so we can see it a little bit better. You have to see Mrs. Gridley there for a moment, okay? There it is. It's sort of shiny, okay? If you look at it there, it's sort of shiny, all right? If we took a hammer and hammered it, it would break into lots of pieces, but I don't want to go ahead and break our countertop. So silicon is another sort of somewhat shiny substance. Silver is our next substance. The symbol for silver is confused with gold often. Silver is Ag, okay? Coming from the Latin name argentum. And we know we have silver. The most common spot you would find silver is silverware, okay? Now, the silver that you normally use, the cutlery that you normally use, you probably aren't using silver all the time, all right? The silver inside of the a china cabinet, a nice china cabinet maybe you have in the house or apartment, this is pure silver, okay? Now, one of the ways you know you're using silver is over time it will tend to tarnish a little bit, okay? There it is, it'll tarnish a little bit. We can go ahead and take that tarnish and remove that tarnish. There's a couple ways of doing that, but that's reacting with sometimes sulfur, okay, and sometimes oxygen. So here's another sample of some silver, and there's some of the tarnish. We can see that tarnish happen. So silver symbol is Ag. Our next element is sulfur. Sulfur is a yellow substance, and where are we here? The symbol is just S, sulfur. There we are, sulfur. Let's go take a look at some sulfur. Pure sulfur is a yellow powder, okay? You can find sulfur around hot spring areas. So if you happen to ever go to a hot spring area, it might smell sort of bad, all right? It's usually the sulfur that might be found all by itself. You don't sniff like this, you waft the fumes, and as you waft the fumes, you'd say, rotten egg smell, okay? That's sulfur. It's also used in explosives and firecrackers and fireworks. So you might burn some sulfur in order to have the fireworks blast off. What is our next substance that we're going to try to take a peek at? We're going to go ahead and find some zinc. Okay, and we have just some small little bit of zinc here. Okay, zinc is also sort of a more dull gray metal. It can also come as a ground up powder. So let's go take a peek at the pieces of zinc. Okay. There's different kinds of zinc. There's mossy zinc, there's granulated zinc, there's different kinds of zinc, okay? So just because you see a powder does not mean it's zinc, all right? Just because you see something gray and dull, you don't know it's zinc necessarily. There are a lot of different kinds of metals that are all very similar. That's why it's so important to have the name and the symbol on there. There we go, okay? ZN, headed upside down. There are a couple of other elements I'd like to show you, okay? One of them is, okay, and that is oxygen. Symbol for oxygen is O. It is about 19% of the air. So almost 20% of the air we breathe is oxygen. It's not 100% of the air, it's about 20% of the air that we breathe is oxygen. Almost 80% of the air is nitrogen. We can't see it, smell it, feel it, okay? We can hear it sometimes, okay? We can feel it, but we don't know it's nitrogen. Nitrogen is about 80% of the air, okay? Everywhere you go on Earth, all right? 80% of the air you breathe is going to be nitrogen. So for every 10 molecules you breathe in, 8 of them are going to be nitrogen. And then 1%, about 1% of the air is argon, leaving less than 1% for all the other gases. Okay, argon symbol is Ar. Okay, you can't smell or notice any argon at all in the air because it doesn't have properties that easily identify it. So those are just a couple of samples of the elements in case we don't get a chance to see you in the fall of 2020. Be safe, and hopefully we'll see you soon. Welcome to Backyard Chemistry again. Here's one element we didn't show earlier. And this element is iodine. It is pure iodine. And as you can see, I'm outside today rather than inside. Iodine is notorious for causing stains. Very, very bad stains. So let's go take a look at the iodine. I poured a little tiny bit out here, and we can see the iodine. It looks somewhat shiny-ish. Okay, the crystals. Now, you might have heard of a tincture of iodine, which is very, very different than this iodine, okay? This is pure elemental iodine. It does not dissolve in water. It does react with a lot of things, and I'm outside today because I don't want to go ahead and put a stain on the countertops. When you talk about iodine in medicine, you're not talking about this kind of pure iodine, you're talking about a mixture of iodine and something else, as well as the fact that the iodine in medicine is often a compound of iodine rather than just simply the iodine by itself. But iodine is highly reactive. It's great at killing bacteria. So if you're doing a surgery site, they'll use either the mixture of iodine or a compound of iodine to help make sure any kind of surgical site is clean.